So here's my graph of 2x squared plus 5x minus 1 divided by x plus 1. Okay, this is my division that I just did. And my quotient was 2x plus 3, and I had a remainder term stuff. So this is my graph. It's a rational function. It's got what we call a slant. It's got a vertical asymptote here. And if I turn on that graph of 2x plus 3, the quotient, notice what happens here. I get this line, the straight line. Now, as I zoom out, notice that this straight line actually starts looking like the graph. Okay, so I'm just going to zoom in a bit. But as I zoom out, that straight line in the red graph start to get closer and closer together as I go to negative infinity this way and positive infinity this way. Well, why is that the case? Well, if you think of your division statement, you had this division is equal to 2x plus 1 plus the remainder over divisor. Okay, so I end up with actually plus remainder negative 4 divided by x plus 1. Okay, that's the exact same graph. But what's happening to this term as x gets really big? Well, as x gets really big, 4 divided by a really, really, really big number is starting to get insignificantly small. So if we start to ignore that, we can see that our original curve is going to start behaving like that straight line. And this is what we call endpoint behavior. And we can start doing this kind of analysis. This is actually what calculus gets into, but we really need to start kind of thinking in this way and thinking of this idea of what's happening as x's get big and what happens to expressions. How are the expressions behaving is what we're going to really start focusing on.